Okay, this is Principles of Technology 1. Well, what exactly is Principles of Technology 1? Well, Principles of Technology 1 covers a couple things. Obviously, it deals with technology. It really deals with systems around us. In other words, how things work is probably a better name for the course. It's a college course that I took in how things work. It was one of the most beneficial college courses I took, in the fact that it kind of explained a little bit about everything around us. Key thing to understand is it's hands-on. I'm going to teach you by doing. We will probably do 60 to 65 labs in this class. I'm a firm believer that that's the way you learn best. Now, it's going to put a lot of emphasis on you taking some ownership of it and actually learning it. I'm not going to spoon feed it to you. I'm going to expect you to be able to read lab manuals, figure out how to do the labs, and so on. Basically, what we have in Principles of Technology is we have 4 systems. We have mechanical systems, we have fluid systems, we have electrical systems, and we have thermal systems. And what this course does is it takes a concept and applies it to all 4 of those topics. For example, the first concept we're going to talk about is force. And then we will talk about force in a mechanical system, force in a fluid system, force in an electrical system, and force in a thermal system. Basically, the force is the why things happen. Okay, why do machines work? Why do motors work? How do bicycles work? Stuff like that in a fluid system. Why does moving fluids allow us to do stuff? Why does it happen in an electrical system? How does your cell phone work? Stuff like that. A thermal system, how does an air conditioner work? It looks at the underlying principles that govern those. Now, let's take a look real quick at each one of the systems just to give you an idea of what we're talking about. A mechanical system. A mechanical system is going to involve moving parts. Now, it can be as simple as something like a bike, and then we can get more complex from there, all the way up to even a race car engine or something like that. But it's basically mechanical systems contain usually 1 or more moving parts, and there's some reason that they move. Now, in a fluid system, what we're going to be doing is looking at moving liquids or gases. Now, that's where this course may go a little bit beyond that. We're either going to use liquids or gases, and when they move, they cause things to work. Examples of fluid systems are things like shock absorbers on cars, but there's a lot of fun ones, paintball guns, super soakers. Those are all examples of fluid systems. Your first test question that you're going to see repeatedly, I'm going to give you today. If it's a gas, it's called a pneumatic system. So like air nailers, air wrenches, things like that. If it's a liquid, it's called a hydraulic system. So anytime you see hydraulics, that means we're dealing with liquids. If you see pneumatics, that means we're dealing with gases. We're going to say that both of those are fluids. Now, in an electrical system, this is a shock. Electrical systems use electricity. So anything that's powered by electricity, obviously a big one nowadays, cell phones, tablets, computers, stuff like that. Now, it's also, we'll cover that later. So cell phones, tablets, anything that's Xboxes, PlayStations, anything that's electrical in nature. Why does it work and how does it work? We'll get into a little bit of that. That's kind of fun. And then the fourth system that we will talk about are thermal systems. Well, thermal means heat. So this is going to be things that heat and cool and how they work. Key thing to understand, probably the single most important thing to understand, it's an inviolate law of physics. Heat always flows from hot to cold, never the other way around. How does an air conditioner work? An air conditioner works by taking heat out of your house. If this is your house, look at that. The man artiste. And what it does is it takes heat that's inside your house and puts it outside. That's why when you walk by the compressor blowing outside your house, it's blowing out hot air. That hot air used to be in your house. So if you take heat outside of your house and put it outside, the temperature of your house goes down. That's why they work. The other thing important to understand is none of these work in a vacuum. In other words, oftentimes our real life systems aren't simplified into just one or the other. Even something like a computer that we all know and love. Yes, it takes electricity in, but inside electricity, you've got fans, hard drives, disk drives, if any of them still have disk drives left. All of those are really mechanical systems that are physically moving. The hard drive is physically spinning. The disk drives are physically spinning the whole time. You also have a thermal system. You have to be able to get heat out of the computer. Otherwise, it'll overheat. And if you can cool it down, it'll work better. Some of the gamers will actually take and put extra fans on their games to make their games run faster. If the games run faster, the CPU runs faster, they might win. You don't really see fluid systems in a computer, but that's just an example of it. I hope you'll have fun in the course. Let me know if I can help you in any way, and we're going to get after it. Thank you.